number patterns. What we think of as a number pattern is in maths called a sequence, and it's just a list of numbers in a particular order. And the numbers in the pattern are called the terms. So, this is how we write a number pattern. Each term separated by a comma and an ellipsis, 3 dots at the end to show this keeps on going. And a lot of number patterns or sequences have a definite pattern and a rule. I mean, you could just make a number pattern by randomly rolling a die and going, 6, 4, 2, 3, and you can't predict anything like that. But mostly we've got a particular predictable pattern. So when we have a rule-based pattern, we've got a couple of strategies to find that rule. Always check first, is there something that we're adding or subtracting from the previous term to get the next term? So always do a quick, 8 minus 2, that's 6, 14 minus 8, that's 6, hang on a second. So by subtracting back, we can find out they added 6 to get each term of this pattern. So you add 6 to the previous term, that's your rule. Sometimes it's not adding the same amount. So this is plus 10, then plus 30. That's not very helpful. Sometimes it's multiplying. So you can look for a multiplier. This one's times 3. This one here, obviously we're subtracting something each time. 7 down to 4. Let's take away 3 each time. So you can often just find the rule by looking at what happened between this one and this one. Sometimes it gets a bit trickier though. This is plus 3, plus 5, plus 7. Now you can sort of see a pattern there if you wanted. Plus 3, plus 5, plus 7, plus 9 for the next one. But there's also often a situation you get where the position is what's happening. Because it's a bit hard to say, well, your rule is add 2 more numbers each time. The position of this term, this is the first term. This is the second term. This is the third term. This is the fourth term. And if you look at the position and the term, you might find it easier to see what the pattern is. They've squared the position. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So a lot of number patterns will rely on the position in the pattern of the term to generate the rule. So we need to be able to do a couple of different things. One of them is generating a sequence from a rule. So write the first 4 terms of the sequence with a starting value of 5 and the rule double the previous number, then subtract 3. Now we've got a couple of ways we can do that. Obviously we start at 5, then we double 5, that would be 10, take away 3, 7. To get the next term, double 7, that's 14, take away 3, 11. The next one, double 11, that's 22, take away 3, 19. We've got the first 4 terms. At that point we can stop. You can put the little dots there if you want, but they did just ask for the first 4 terms. The calculator is really good for these. Now this is called a recursive sequence or recursion, where you use the previous number and do the same calculation each time to get the next number. Calculator's good at it. Put in the first number and press enter. So 5, turn the calculator on, 5, enter, and it's stored over here. Then I need to multiply by 2 and subtract 3. If you do times 2 minus 3, it takes the previous value of 5 multiplies by 2 and subtracts 3. Hit enter. 7, hit enter again. 11, hit enter again. 19. So any recursive number pattern where you use the previous value to get the next value, you can get on your calculator with no worries. And the last thing we should probably mention is I said that the position in the pattern is often very important, and that each of these is known as a term. And so it makes a lot of sense that this is term 1, this is term 2, term 3, term 4, and term 5. We write that as T with a little subscript 1. When you use a subscript in maths, it's an identifier, it's naming it. So this is saying this is term 1, this is term 2, term 3, term 4, term 5. And so they wanted me to identify term 1 and term 4. Term 1 is 2, term 4 is 20. So this is appropriate or important notation. Knowing what T1 means, we're looking at term 1, the term in the first position of a number sequence.